Okay, class, today we're starting exponential graphing. So in Algebra 1, you did learn exponential. And so the parent function for exponential is y equals b to the x. And b can be any number. And so the parent function, it doesn't matter what b is, that'll still be a parent function, okay? And then we're going to learn about how this transforms. So if b is greater than 1, then you're going to get an exponential growth, okay? Which means the graph will be increasing. If your b is less than 1, then you're going to get exponential decay and the graph will be decreasing. Okay? With exponential graphs, we have something called an asymptote. Okay, what this is it's an imaginary line and it's a value that the graph approaches but never crosses. So it'll get closer and closer and closer, but it won't actually cross. So I have an example, number 1 here. And so if we graph f of x is equal to 2x, 2 to the x, this is a parent function because all it has is a b to the x. So this is a parent function. There's no transformation yet. So we'll show one in a minute. If I graph this in the calculator, this is the table I get, the XY table. Okay, and it's always good to get some negatives, 0, and some positives. And so if I graph this, I'm going to say, okay, negative 2.25. I have negative 1.5, 0, 1, 1, 2, and 2, 4. Okay, and this will keep going. You can look in the graph and you'll see that it keeps going. And so we get this kind of curve here and it's going to keep going. So we have an arrow here. What happens down here though is it's going to get closer and closer to 0, but it's actually not going to touch. And so that's where our asymptote is. So if you went and looked at negative numbers that are less than negative 2, so like all the way to negative 9, for example, you'll see that it gets really close to 0, but it doesn't actually touch 0. And so we know our asymptote then in this case is y equals 0 because it's not going to actually touch it. Okay. Our domain here is the x values. And so all the x values are here and we can use any of them. So our domain in this case is all real numbers. Our range, however, are our y values, and because we have this asymptote at 0, we know that none of our y values are going to be negative. So really our y values are all greater than 0. Okay. The last thing we talk about is end behavior. So as my x values go in the positive direction, what's happening to my y values? And in this case, the end is going up as well. So the y values are also going towards positive infinity. Okay. Now what happens when my y values go negative? I'm sorry, my x values. So as my x values go negative, my y values are just getting more and more constant. They're actually approaching 0. And so in this case, we'd have it approach 0. Our y-intercept is just when x equals 0, and we can actually see that in our table here. So when x equals 0, y equals 1. So our y-intercept in this case, you can write as 0, 1. Okay, and so that helps us graph these exponentials. That's kind of all of Algebra 1. If we go to page 3 of our packet, we have transformations. And so now this is where we're talking about, okay, well, if I take the parent function, how can I transform it? And so remember, the parent function is still this b to the x, okay? That's still my parent function. Now what happens, though, is if I have an h here, And so just like my other h's in absolute value, in square root, the h is a liar. It lies to us because it's next to your x. And so if it's a negative h, it's actually going to go to the right. And if it's a positive h, it'll go to the left. So it is a horizontal shift because it goes left or right. Okay. And then again, if it's positive, it's really going to the left. And if it's negative, it's really going to go to the right. Okay. So again, that's up here. It'll be right next to your x value. If we then look at the k, right, we have k right here. K is as is. It's not a liar. So in this example, K, if it's positive, it's going to go up, and if it's negative, it's going to go down. This is a vertical shift, which means these are your up and down shifts, okay? So if it's a positive K, it's going to go up, and if it's a negative K, it's going to go down. Okay, the last one we want to talk about is A. And so A has to be a number in front of B. A lot of mistakes are people think it's B, but it's not. It's another number in front of it. Okay, so not all of our functions are going to have that, and that's okay. So if A is negative, the function is going to flip over or reflect across the x-axis. Okay, so it's going to flip over. Reflect across the x-axis. Okay. Now, if we talk about A and its absolute value, if it's greater than 1, basically a good way to remember this is if A is a whole number, okay, if A is a whole number, then we're going to get a vertical stretch. Where if A is a fraction, we'll get a vertical compression. Okay, so let's take a look at a couple of these real quick. If we're looking at number 1, for example, and this is all you have to do for the classwork, there is no A value. Our parent function right here is 3x. And so all it's asking is identify the parent function. And so in this case, the parent function is 3 to the x. And then what moved? What was the transformation? And so in this example, our only movement is over here on the outside, which is a k value. And so our parent function is 3 to the x, and the transformation, in this case, it's a positive 5, and it's a k value, so it went up 5 units. Okay. And so if you look, I do have the answer key up, so why don't you practice a few of these and see if you get them right. And then the classwork that's for an assignment is still graphing just more of these. So just knowing how they change, that's our big point for the homework. Okay, I will see you guys tomorrow.